All right, welcome. Today, we're going to pull back the curtain on something that pretty much powers our entire digital world, the standard AWS architecture for deploying an application that's secure, scalable, and just really solid. We're going to build a digital fortress, piece by piece.
Okay, let's just dive right in. Think about it. We use apps every single day that just work. They're always on, always secure. But how? How do they pull that off? Is it just, one giant, super powerful computer sitting in a basement somewhere?
Well, spoiler alert, it is not magic. It's architecture. The secret sauce is a really well thought out blueprint, a plan that's designed from the ground up to handle traffic, to protect data, and maybe most importantly, to expect things to fail and be ready for it.
And that really brings us to this tale of two deployments. On the left, you've got the simple setup, one server, wide open to the internet. It's easy, sure, but it's also a ticking time bomb. It's one power outage away from going dark, and it'll just fall over if you get a big spike in traffic. But on the right, that's the goal, a professional, production-grade setup. It's multi-layered, it's secure, and it's built to scale.
So let's start building. The very first thing we need to do, the most critical step, is to build the outer walls of our digital fortress. This is the foundation that's going to separate our private world from the chaos of the public internet.
And that foundation has a name, the Virtual Private Cloud, or VPC. Just think of it like this. You get your own private, completely isolated piece of the AWS cloud. It's like your own plot of land, and the first thing you do is put a giant, impenetrable wall around it. Nothing gets in, nothing gets out, unless you say so. This is square one for cloud security. Now, inside our fortress, we don't just throw everything together. We create zones. First, you've got the public subnet. This is like the castle's outer courtyard. It can be seen from the outside world, but it's heavily guarded. This is where we put things that absolutely have to talk to the internet. And then you've got the private subnet. This is the inner keep, the most secure part of the castle. It is completely 100% cut off from the internet. This is where our most valuable assets, our actual applications, are going to live.
Now here's a pro move. We don't just build one fortress. To be truly resilient, we build our entire setup across at least two physically separate data centers. AWS calls them availability zones. So, why two? Well, if a power grid fails or something catastrophic happens to one entire building, our app doesn't even blink. It just keeps running from the other location. It's the ultimate backup plan.
Okay, our walls are up, our zones are defined. Now it's time to place the crown jewels, our actual application servers, safely inside that secure inner keep, the private subnet.
And this is where things get really smart. We're not just going to stick one server in there and call it a day. Nope. We use something called an auto-scaling group. This thing is amazing. It's an AWS service that basically manages a whole fleet of our servers for us. Think of it like a general who automatically calls in reinforcements the second the battle gets intense. So how does it work? It's actually pretty simple. You just give it a few rules. You say, hey, I always want at least two servers running no matter what. Then you say, but if we get a huge rush of users, you have my permission to spin up, let's say, 10 servers. The auto-scaling group just sits there, watches the traffic, and adds or removes servers all by itself. Your app stays fast, and you're not paying for servers you don't need. Okay, so our app is safe, it's secure, it can scale, but we have a new problem. It's completely locked away from the world. No users can get in, and our app can't get out to download updates. We need to build some very specific, very secure gates.
Gate number 1 is the main entrance, the one for your users. This is the application load balancer. It lives in that public courtyard we made, and it acts as a brilliant traffic cop. It greets all the incoming traffic and then smartly distributes it across all our healthy servers in the private area. This makes sure no single server gets overwhelmed.
Gate number 2 is like a secure exit door. What if our private application needs to go out to the internet to grab an update or get data from another service? That's what the NAT gateway is for. It lets our private servers make connections out to the internet, but, and this is the crucial part, it prevents the internet from ever starting a connection back in. It's a one-way street, keeping our app's location a secret.
And finally, gate number 3. This is the secure service entrance, just for your administrators and developers. It's called a Bastion Host, or sometimes a jump server. It's a single, heavily fortified server that lives in the public subnet. It is the only way for a developer to securely get inside and manage the private servers. This gives us one single point of entry that we can watch like a hawk. So let's do a quick recap of our gates, all living in that public subnet.
We have the load balancer. That's for your end users. We have the NAT gateway. That's for your application itself. And we have the Bastion Host, which is for your developers. Each one has a very specific job, and together they give us total control over who and what gets in and out of our fortress. All right, we have laid the foundation, we have built the walls, we've deployed our app, we've installed the gates, all the pieces are in place. Now, let's see this thing in action. So, picture this. A user types in your app's address. That request flies across the internet and hits our first gate, the application load balancer. The load balancer takes a look, sees which of our private app servers are healthy and ready, and forwards the request to one of them. The app does its thing, sends the response back the same way it came, and the user gets what they wanted. It's simple, it's elegant, and it's incredibly secure. And you should know, this isn't just some cool idea someone came up with. This is the industry standard. As Abhishek Vieramala, the creator of the guide we're following, points out, this is the exact approach that AWS themselves recommend for anyone who's serious about deploying a secure, production-ready application. So, why do all this? What's the big payoff? Well, you get layers of security that shield your most valuable assets from attack. You get high availability, because your app literally exists in 2 places at once. You get incredible scalability that just handles traffic spikes without you lifting a finger. And you get total, auditable control over who can touch your infrastructure. So there you have it, the complete blueprint for building a digital fortress in the cloud. It's the standard for a reason. It creates applications that are secure, resilient, and ready for pretty much anything. The plans are all laid out. The only question left is, what amazing thing are you going to build inside?